Hello and welcome to the first e-video lesson of this week. Today we're going to focus on the notes for Parallelogram Properties number 13.1. Now a note about these videos, what I suggest you do as you go along, feel free to pause the video from time to time in order to write down anything you need to before moving on to the next problem. I will remind you to pause the video at periodic points in this video, but feel free to do so at any point you want to. Hit back button if you miss something. If you want to review something, just hit the back button. Hit rewind. Okay. So let's get started with the first part of the notes, which is defining what a parallelogram is. By definition, a parallelogram is a quadrilateral that has two pairs of parallel sides. Two pairs of parallel sides. So a diagram of a parallelogram looks something like this. We have one side that's parallel to another side, and then you have another side that's parallel to the other side. Okay. Different sets of parallel sides have different arrowheads on them. Notice the ones on the left and the right have one arrowhead. Those are going the same direction. Those are a set of parallel sides. And the top and the bottom have two arrowheads because those are parallel to each other. Okay. That's what a parallelogram is. Pause the video, write down anything you need to before moving on. So what we're going to do is we're going to look at several properties of parallelograms, dealing with their sides, their angles, and with something called a diagonal. Okay, the first property that we're going to look at is dealing with the interior angles. Okay, in a parallelogram, opposite angles are congruent. What this means is if you're given a parallelogram, and just for the sake of today's lesson, I'm not going to mark the sides parallel just to save some time. But opposite angles, for instance, those angles are going to be congruent. And these also are another pair of opposite congruent angles, so they are going to be congruent. So in the examples below, you want to find the value of x. You're looking for the opposite angles. So x and 115 are opposite. So in this case, x is 115 degrees. Go ahead, pause the video now and finish the next two, then I'll go over them. Okay, let's see how you did. So x and 73 are the opposite angles, so x is 73 in letter B. And 4x plus is opposite from 2x plus 64, so hopefully set up an equation 4x equals 2x plus 64. You just got to solve that, subtract 2x from both sides. End up getting 2x equals 64. Divide both sides by 2. X equals 32. Pause the video, write down anything you need to before moving on. Okay, now let's look at the second property of parallelograms, and these are dealing with their sides. Now in a parallelogram, opposite sides are also congruent. Okay. So if I draw a parallelogram, that means that the left and right sides are going to be the same, the top and bottom sides are going to be the same. Alright, now let's look at example A, set up an equation to solve for x. Well, x and 33 are across from each other, so x is going to be 33. Okay, pause the video now, finish the rest, and then compare your answers in a moment. Alright, so you should have seen that 7x plus 4 and 9x minus 12 are opposite each other. So 7x plus 4 is going to be equal to 9x minus 12. When you solve that equation, subtract the 7x from both sides, you get a 2x on the right side. Add the 12, you get a 16 on the left side. Divide by 2, x is 8. Sometimes, just like in the last set with the angles, you have extra information. So keep that in mind. Sometimes you will be given extra information that you won't need to use. Letter C. Opposite sides are equal, so you have x squared plus 4 is equal to 2x plus 7. Okay. Now notice this ended up being a quadratic equation because we have an x squared term and an x term and a numbers. So we have to make it equal to 0. So subtracting the 2x from both sides gives me this equation. And then subtract the 7 from both sides gives me an equation equal to 0. So x squared minus 2x minus 3 is equal to 0. Now we solve these using the factoring method. Two numbers that multiply to the negative 3 that add to the negative 2. Those two numbers that work are going to be the negative 3 and a positive 1. Because negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. And then we're going to apply the zero product property to solve for x. So x minus 3 has to equal 0. X plus 1 equals 0. In other words, each factor must be equal to 0. So x is equal to 3. X equals negative 1. Now with these ones, what you want to do, and maybe you didn't do this, but you want to check the values into the diagram and see if they give you positive lengths, especially ones with quadratics in them. So for instance, if I plug into the 2x plus 7, doesn't matter which one you plug into, I'm choosing that one because it doesn't have a square. If I plug in 3, 2 times 3 plus 7, 6 plus 7 is 13, that is a good side length. Plug in negative 1, 2 times negative 1 plus 7, negative 2 plus 7 is 5, that is a good side length. In this case, both values work, so the 3 and the negative 1 are both solutions to this problem. You will encounter some situations where either a positive or negative will provide a negative side length. In that case, you would eliminate those choices because it doesn't work in the diagram. Pause the video, write down anything you need to before moving on. The next property deals with something called a diagonal. Okay? And the diagonal is just essentially a segment that connects two non-consecutive vertices. A segment that connects two non-consecutive vertices. Now that's kind of wordy, okay? So let me just explain through just different types of polygons. So if you had, for instance, a six-sided figure, you have several different diagonals. Because a diagonal is formed by connecting non-consecutive vertices. So for instance, here to here, here to here, there to there, those are all diagonals. Okay. Now the reason why it has to be non-consecutive is because if you look at consecutive vertices, vertices meaning all the corners, there's already a term for that. That's a side of the polygon. Okay, so this right here is just one of several diagonals in that hexagon. Now today we're focusing on parallelograms, and what you'll notice is that there's only two diagonals in a parallelogram. And there will be a special property we're going to look at in a second, but pause the video and write down anything you need to. Okay, this last property deals with the diagonals. And let me just draw the picture. Maybe you can kind of see what's going on before we write it out in words. If I were to draw both diagonals, notice that where they intersect splits the other diagonal in half. So these two are going to be equal, and these two parts of the diagonal are going to be equal. So what happens is that the diagonals bisect each other. I mean, splits each other in half. The diagonals bisect each other. Or in your terms, split each other in half. Okay, which allows me to say things like this. If I have a parallelogram, diagonals, I can have maybe a length of 5 and 5 and 8 and 8. Okay, that's how those will be labeled. So for instance in letter A, here's the intersection point, so these parts have to be equal, so in this case x is going to be 5. The 17 is extra information in letter A. You could put it over here if you really want to, but you don't have to. Okay. Letter B, they intersect here, so x is going to be 19, because these two parts are going to be equal to each other. The 12 will go up to this part right there. Now letter C, notice I did not label the diagram, but I gave you the lengths of AE, DE, and CE. Those are all parts of the diagonals. So you have to figure out which ones are going to be equal to each other. This is going to be extra information here. AE is here. DE is here. It's on a different diagonal, so it's going to be a different length. CE is here. So that's telling me that AE and CE are the two that are equal to each other. We don't have EB, so I can't use this. This is extra information. So I'm going to set up an equation. 15x minus 23 is going to be equal to 10x plus 48. Solve that equation. Subtract 10x from both sides. I get a 5x on the left. Add 23 to both sides. I get a 71 on the right. And divide both sides by 5. I get 14.2. Remember, decimals are okay. You might get some decimal answers, so keep that in mind. Pause the video, write down anything you need to. Okay, now here are some 3 practice problems, mixing all the properties together. What I want you to do is take a moment, pause the video, and solve each one of them, and then we'll hit play again, and you'll check your answers. So go ahead, pause the video now and try all 3 of these. Okay, number 1, we have opposite sides, so they're going to be congruent, so x squared plus 3x has to equal the 10x plus 8. When you solve this, because it's a quadratic, you have to make it equal to 0, so subtract the 10x, subtract the 8. You should have gotten the equation x squared minus 7x minus 8, because 3x minus 10x is 7x, negative 7x, and then you get the negative 8. Factor it. The two numbers that multiply to negative 8 that add to negative 7 are going to be negative 8 and positive 1. Then hopefully apply the zero product property. Set each factor equal to 0 and solve for x. So x equals 8 and negative 1. And then you want to check to see if you can eliminate any answers. So I'm going to choose the 10x plus 8 because it's not dealing with a square. So if I check 8, 10 times 8 plus 8, that gives me 88. That's a good side length. 10 times negative 1 plus 8, negative 2. Okay, so there's one that won't work. So therefore, we can eliminate that negative 1 as an answer. So the only answer to this problem in the diagram is going to be 8. Okay, number 2. What I did is I maybe labeled all the angles. 17x minus 15 is here. Angle B is 10x plus 7. And then angle C is 16x plus 9. And very clearly I can see now that opposite angles are going to be A and C, and they're going to be congruent. So angle B is extra information. So 17x minus 15 has to equal 16x plus 9. Solving that, we get x equals 24. All right, and now you may notice I chose some values there, number 2, that if you plugged it in, it gets you some really strange angle measures. Let's see, 17 times 24 minus 15 gives me 423 degrees. So just ignore that fact. Okay, if you got 24, you solved it correctly. All right, number 3, AE, EC, and BE are the given lengths. So AE and EC are the two that are along the same diagonal. They're going to be congruent. So BE was the extra information. So 8x minus 12 is equal to 7x plus 27. Solving that, we get x equals 39. And there we go. There's our answer. Alright, pause the video, write down anything you need to before moving on. Alright, so let's just sum up this lesson. Okay, today we looked at 3 properties of parallelograms. So first, the definition of a parallelogram is that you have opposite sides that are parallel. 2 pairs of opposite sides parallel to each other. We looked at opposite angles are equal. We also looked at opposite sides are equal. So let me just draw some separate diagrams. So these sides are equal, those sides are equal. And we also saw that the diagonals in a parallelogram bisect each other, split each other in half. Meaning these 2 parts of the diagonal are going to be equal, and these 2 parts are going to be equal. Okay. So now that you've finished watching this video, raise your hand and I'll come give you the homework for tonight so you can start it in class. Okay. Write down anything you need to, and I'll see you in the next video. Thanks.